All right, this is actually maybe one of my favorite lessons of the year. The reason for that is it really feels like you're doing math. There's no graphing here, there's no strange terms, it's just solving for x. And the reality is it's not very difficult. Most of your mistakes are going to be, computational errors, making mistakes with fractions, that kind of thing. Okay, let's take a look at the question. An exponential equation, so the equation contains a power with a variable in the exponent. So this is where it's different. Having a variable in the exponent, we haven't seen x in the exponent and having to solve it yet. Okay, one strategy is to graph in calculator. You don't get that in grade 12. Okay, and then trying to do this with curves intersecting. So, for example, if you think of some of those curves we just had, if you had one like this and we had one like this, and we wanted the solution, we would want to know what is the x value where the two graphs cross. Okay, you will not be expected to do that. The way you're going to do these is to solve them algebraically. Okay, so let's take a look at this. And to do this, we want to try to figure out what is the x value that makes this equation true. You're not going to be able to do these with guess and checks. Okay, to do them, you're going to try to make the bases the same. So if you look at 16 and 32, those are the bases here. How could we make them the same? Well, hopefully you recognize that 16 and 32 are both powers of 2. So I could write 16 as 2 to the power 4, and I could write 32 as 2 to the power 5. Now, how would you know that? Well, hopefully you remember that you had to memorize those in grade 9 and 10. Okay, the questions you will get will usually be bases 2, 3, 4, 5. They shouldn't be too big, and they should be in that range that we've memorized in the past. Okay, so if you can do that, you can do these questions. The mistakes I find are usually computational, where you make little mistakes forgetting what are your rules for exponents and fractions. Do you remember what the rule is when you have power to a power? You have to multiply these powers. So this is going to be 2 to the power 8x minus 12. And this would be 2 to the 5x plus 15. By the way, the number of times I've seen 5x plus 3, wow. Remember that this 5 has to be multiplied to both terms. Okay? And now once the bases are the same, since we have this equal sign here, this must mean that this and this are the same, because 2 to the power of this something equals 2 to the power of this something. So we just have to equate the powers in. So 8x minus 12 has to be equal to 5x plus 15. Okay, and then it's a simple algebra question. Take away 5x from both sides, you get 3x. Add 12 to both sides, you get 27. Divide by 3, x is 9. Okay, let's try another one. Hopefully you recognize those are powers of 3. So I could write this as 3 cubed to the power x, and I could write this as 3 squared to the power 2x minus 1. Now power to a power, this is 3 to the 3x, and this is 3 to the 4x minus 2. Again, since the bases are the same now, the exponents must be the same. So I can take away 4x from both sides. I get negative x is negative 2, so x is 2. Okay? Now, those are your very basic questions. Now you get ones like this. There's a little twist to them all the time. Okay? You probably recognize that 4 and 256 are both powers of 4. Okay? But this is in the denominator. So let's do one step there first. How could I make 256 be in the numerator? How could I do that? How could I make it disappear like that? That's pretty interesting. It just disappeared on me all of a sudden. Where did it go? Okay, I think I've got it back working here now. I could put 256 back up there by writing 256 to the power of -1, right? That's the reciprocal. So now this lets me go 4 to the power x. 256 is 4 to the power of, well, let's think about it. 4 squared is 16. 4 cubed is 64. 4 to the power 4 is 256. So it's 4 to the power 4 all to the -1. So I get 4 to the power x is 4 to the power -4. This means that x is -4. Okay? Now another little twist. The root sign. You need a little refresher here. Do you remember is the same as x to the power of a half, right? Because there's a little 2 in here. Do you also remember that if it was x to the power 3, it would be the same as x to the power 1/3? In fact, if it was x to the power of to the root n, this is x to the 1 over n, whatever that might be. That's from grade 10. I know that's probably a long time ago, but let's see if we can apply that here. So let's rewrite that root sign. Instead of the cube root of 2, I'm going to write it as 2 to the 1/3. Alright, and then I'm going to change that 8 to 2 cubed. And then I want to combine this. What's your rule when you multiply powers that have the same base? You add the exponents. So it's 3 plus 1/3. So you get 2 to the power x is, what is 3 plus 1/3? 3 over 1, which is the same as 9 over 3. So this is 10/3. Alright, so x is 10/3. Okay, let's try this one. So we've got a couple things. We've got bases that are different, and we also have radicals that are different. So let's change some things here. I'm going to write this as the square root of 5 cubed. So you could do this in one step, but I'm going to do it in two. And then I'm going to write this as the cube root of 5 to the power of 4. Okay. So then I'm going to take the radicals now. So this is 5 cubed, and instead of the root, I'm going to put to the power of a half. And here, instead of the cube root, I'm going to put to the power of 1/3. Now here you have power to a power to a power. You need to multiply this. Okay, so you're going to get 5. 3 times a half. Let's do it in two steps. So 3 halves. And here you're going to get 5 to the 4/3. Again, I told you you're probably going to make a mistake with the fractions. How did I get 4/3? 4 times 1/3 is 4 over 1. And so you do not need common denominators to multiply fractions. Okay, so then we're going to get 5. What's 3 halves times 2? It's 6 halves, which is 3x, plus 3 halves equals 5 to the power of 4/3. Now you can make the powers equal. Alright, how do you do this? Well, let's take away 3 halves from both sides. So you get 3x is, what is 4/3 take away 3 halves? Well, let's make common denominators here. 8/6 take away 9/6. Okay, so in case you're not sure, where did this come from? This is 4/3 take away 3 halves. And I made common denominators. Okay, so you get 3x is -1/6. Let's take that over here. If I want x now I have to divide by 3. So negative 1/6 divided by 3. This is negative 1/6 times 1/3. And you get negative 1/18. So if you look at that question, there's a lot of fraction work in there. You really need to be good at fractions. Okay, next one. These are all powers of 3. So let's change them all to powers of 3. 81 is 3 to the power 4. 243 is 3 to the power 5. And this is just 3 to the power 4. Okay, let's combine. You get 3 to the 12n plus 8 and 3 to the negative 5n. Okay, do you remember what to do when you when you divide bases that are the same? Yeah, you subtract the exponents. So you're going to get 3, and what goes here? This is 12n plus 8, take away negative 5n. So 12n plus 8 plus 5n. So you get 17n plus 8. And that means 17n plus 8 is 4. 17n is negative 4. N is negative 4 over 17. All right, that is the end of this lesson. Page 364 is the homework, numbers 3 to 10. All right, next lesson we'll start some logs, so make sure you're good at the exponential stuff so we can move on.